Well, we're talking about three-dimensional vectors now. So we had I and j, those are the same as the x and the y direction. And now we've got a k component, which is the same as z. Yeah, z direction. So I've got two vectors here. This part of the k is missing over here. Let me fix that, okay? So here's one vector, here's the other vector. And, I numbered them in the little drawing program that I'm using, Rhino. So I've got vector 1 over here and vector 2 over here. So let's take a look over here in Rhino. The green is the y-axis, the red's the x-axis, and then the z-axis, I don't know, they don't really, draw a line that's vertical that I see. It's just the x and the y-axis. But if you kind of look here, this blue one is vector 1, right? So you can see that it's kind of going, how should we say this? It's going in the negative y direction. See like this is the y-axis right here, and it's going that way. And it's going up in the z direction, and it's going to the right in the x direction along this red line. So that kind of makes sense, right? It's going to the right. It's in the x direction, and then it's going down in the y direction, but then it's going up in the z direction. This one's 1, 1, and 3, so they're all positive. Let's see if we can see that in the drawing here. Oh boy, here's the x-axis. See how it's kind of going, it's going out to the right. Here's the y-axis. See how it's going that way, and then the z-axis, it's going up, right? All right, well, the only thing these vectors are missing is little arrows on the end. I'm not sure how to get Rhino to put little arrows on the end because it's drawing a line segment, not really a vector, right? So anyways, that's a little visual for you. We're going to do the dot product just like we did before. So v dot w is equal to the 1 here times the 1 over there. Oops, my arrow went a little too far. So we've got 1 times a 1 plus a negative 1 times a positive 1, right? And then we've got a 2 times a 3. So this is the dot product. It doesn't seem like, it's so simple, how can it be useful? Well, we've got a 6, I think, if I'm doing my arithmetic right. It comes into play when you're trying to find the angle between the two vectors. Angle between, let's say, v1 and w2. Okay, so vector 1 and vector 2. So how do we do that? Well, it's cosine theta is equal to v dot w all over the magnitude of v times the magnitude of w. Now, three-dimensional Pythagorean theorem works the same as two-dimensional Pythagorean theorem. So let me come up here and put down magnitude. I guess we need that, don't we, for our formula? So the magnitude of v, okay, so we got 1 and 2 here, is the square root of the components squared. So 1, 1, and 2. So I've got 1 squared, 1 squared, and 2 squared. Now I never put the negative down when I'm squaring something. It's not necessary, right? Negative square is going to be a positive anyway. So what do we got? We got 4, 1, and 1, which is 6, I think. So we got the square root of 6. For that, don't get confused with the dot product, right? I mean, it happens to be the same number underneath the square root sign, but that's just by chance. So we've got the magnitude of w, square root of 1 squared, 1 squared, and 3 squared. So 1 squared, 1 squared, 3 squared, that's 9, 10, 11. So we got the square root of 11 here. Both these numbers are going down in the denominator, right? So the dot product up in the numerator, and then the square root of 6, square root of 11 in the denominator, okay? Whew, all right, so what do? We jump over to Desmos, right? And we do the inverse cosine of this stuff, this number right here. We want the inverse cosine of that stuff. Let's practice that real quick, okay? So getting over to Desmos, and you go to degree mode. I think they're going to want it in degrees. And then we go inverse cosine, right? Inverse cosine. We had a 6 in the numerator, and we had square root of 6 times the square root of 11, didn't we, in the denominator? So I'm getting about 42 degrees. Could you check that for me? See if you can get about 42 degrees on your computer. So 42.4 degrees. I'll round to the tens place because I think the homework wants you to round to the tens place. All right. Well, I hope I'm making this clear. It's pretty straightforward. It's not that much different, right, than two-dimensional vectors. All right. Thanks for watching my video. I really appreciate it.